Hi, in this video, we will determine the longest output of this data range, x and y. You enter the longest formula or longest function for this data range and show the complete statistics. Next, we will calculate each of these outputs using the matrix operation. To do that, we will use the logarithm. So we convert this to its logarithm because the regression is exponential. So we have ln y equals matrix x times the matrix of the logarithm of the coefficients, ln bo or b0 and ln b1. So let's start with the ln y, which is our formula. Ln of y. Next, we complete the x matrix. We have the 1 column and the x column. Our formula of the x values. Now that we have completed the expression, we can now start deriving or calculating for the matrix of the coefficients, the ln of the coefficients. So we begin with this matrix and then this matrix. This matrix is inverse. Inverse multiply transpose of this matrix. And itself. Next, we multiply this matrix, the transpose of this matrix, to the ln y values, which is equal to m mult transpose the y values, the ln y values. Now that we have these two matrices, we can multiply to get the coefficient, the ln coefficient matrix. So this is equal to m mult, this matrix, and this matrix. So we now have the coefficients, the ln coefficient matrix. So we can derive the value of coefficient BO, or the intercept, which is equal to exponent BO, ln BO, that's 5.42, which matches with this. And this using the same formula, exponent of B1. So it's 1.23. Next, we calculate the y hat. But before we do that, we complete these two values. This is the variance of population y. We will need these values later on. And the population, which is equal to rows of the dataset range. So we have a population of 9. Now we'll calculate the estimate ln y hat, which is equal to the product of this matrix and our coefficient. So this matrix, you don't need to transpose, and the coefficient. So that is our y hat, ln y hat. Now we can calculate the residual sum of squares, which is equal to sum x m y, or the sum squares of differences of ln y and ln y hat, which matches to our longest output. Next, we calculate the regression sum of square, which is equal to n times variance of population y minus RSS, or the residual sum of squares. So 2.135, which matches to our longest output. Then we calculate the degrees of freedom, which is equal to n, the population, minus columns, or the total number of variables, both dependent and independent variables. So you have a different degrees of freedom of 7. Then we calculate the standard error estimate, which is equal to square root of RSS divided by degrees freedom, which is 0.0646, matches to our longest output. Then we can calculate the F statistics, which is equal to ESS divided by 1, because we only have one independent variable, divided by standard error estimate square. It's 510.47, 510.47 points. So it matches to our longest output. Then we calculate the coefficient of determination, also known as R square or RSQ, is equal to ESS divided by 9, or the population, times variance of population Y. So 0.969864 matches to our longest output. Then we calculate the standard error value of the slope, which is equal to standard error estimate times the square root of J13. And the standard error value of the y-intercept, which is equal to standard error value times the square root of I12, and matches to our longest output. This completes the derivation of the longest function's output.